Okay, in this video we're going to talk about dividing fractions. So if you take a second and think, what is the rule for dividing fractions? Like, for example, if I wanted to do 4 divided by 2/3. So take a second and think about what the rule would be. Okay, so lots of people forget the rule or just don't quite do it right. And the rule is, depending on how you learned it, keep, change, flip, or sometimes it is multiply by the reciprocal. Those are probably one of the 2 ways that you learned it. There may have been something different, but it's, in essence, it's all the same thing. So keep, change, flip is keep the first number the same, so you keep it as 4. You change you change division into multiplication, and then you flip the second thing. So it actually turns into 4 times 3/2. Okay, so why is that the rule? Well, the reason why that is the rule is because I could rewrite this as 4 divided by 2/3 like that. Okay, and that is like a fraction in a fraction. It's kind of mess. So I think to myself, like, how could I change this number 2/3 on the bottom into something easier to divide by? So how could I change it into like a whole number? Well, I could change 2/3 into 1 pretty easily. And I could do that by multiplying 2/3 times 3/2. And the reason why that changes it into 1 is because then I get 2 times 3 is 6, 3 times 2 is 6, and 6 divided by 6 is 1. So that's all going on in the denominator here. And that's much easier to divide something by 1 than it is to divide it by 2/3. Well, you can't just multiply some random part of a number by another number and keep it the same. Like, for example, when you get your paycheck, you can't just multiply your paycheck times 2 and keep it the same. It'd be nice if we could, but that's not the way math works. So, to keep this the same, whatever I do to the bottom of the fraction, I have to do to the top. So, I would have to multiply the top by the same thing. So, on top, I get 4 times 3/2. I'm not actually going to work it out. But so that's the reason why I went from, it's in a different color, I went from the blue of 4 divided by 3/2 to, 4 divided by 2/3, all the way over to 4 times 3/2. Okay, again, saying it all again, 4 divided by 2/3, I multiplied the bottom by the reciprocal right here so that I could get a 1 on bottom. Whatever you do to the bottom, you have to do to the top. And so I end up with 4 times the reciprocal on top of 1. Okay, so dividing fractions, I think, is one of the hardest things for students to think about, for adults to think about. Like 4 divided by 2/3. Like, I feel like the majority of the population, if you ask them 4 divided by 2/3, is that going to be a number bigger than 4? Is it going to be a number smaller than 4? Is it going to be a fraction? Is it going to be a whole number? I feel like most people couldn't answer that question at all. But if you think about it in terms of models, it's not quite as bad. Okay, so for division model, we can do repeated subtraction or partitioning. We're going to kind of do like a little bit of combination of both here. So let's do a line model, or use a line model first, and then we'll use an area model. Okay, so if I wanted to do 4 divided into 2/3. So, a couple ways you could do it. The main way that's the easiest to do is, the thought process is, think, how many groups of 2/3 do I need to make 4? Or to get to 4. So this is kind of like repeated subtraction, but I'm kind of thinking in terms of adding instead of subtracting. So, like, how many times do I have to add up 2/3 to get to 4? And if you explain it like that, how many times do I have to add up 2/3 to get to 4? Well, it's going to be a number bigger than 4, because 2/3 isn't a whole. Like, if it was dividing by 1, it'd be 1, 2, 3, 4. This is a little bit smaller than a whole, so it's going to be a number bigger than 4. So on our number line, Let's draw a number line. I need to get to 4, so I need to end at 4. So let me draw my holes. Here's 1, 2, 3, 4. And then I'm adding groups of 2/3, so I need to split each hole into thirds. So this would be 1/3, this would be 2/3, that would be a hole, 1 and 2/3, I'm sorry, 1 and 1/3, 1 and 2/3, 2, 2 and 1/3, 2 and 2/3, 3, 3 and 1/3, 3 and 2/3, and then 4. Okay, so how many groups of 2/3 do I need to have to get to 4? So here's my first group of 2/3, from 0 to 2/3. I'm gonna put a 1 above it because that's my first group. My second group, I'm gonna go up 1/3, 2/3 more. So that's my second group of 2/3. My third group of 2/3, go up 2/3 more. My fourth group of 2/3, go up 2/3 more. My fifth group of 2/3, go up 2/3 more, and we're doing this until we get to 4. And my sixth group of 2/3, go up 2/3 more, and here I end at 4. So how many groups of 2/3 make 4? 1, 2, 3, 4, 5, 6 groups of 2/3 make 4. So my answer for 4 divided by 2/3 is 6, because it takes 6 groups. So I hope that picture helps you see why the number 4 divided by 2/3 is a bigger number than 4, because it takes that many times to get to 4. Okay, so let's do the same problem using an area model. So same idea, I'm just doing an area model instead of a line model. Instead of like a number line, I'm gonna use rectangles. So same problem, 4 divided by 2/3. So same thought process. How many groups of 2/3 to get to 4? So how many groups of 2/3 to get to 4? Okay, so if I want to get to 4, I'm going to have 4 rectangles here, 4 holes. 2, 3, 4. There's my 4 holes. If I'm splitting these into groups of 2/3, I need to split them into thirds. So here's my 4 holes, splitting into thirds. So how many groups of 2/3 does it take to get to 4? Well, here's one group of 2/3 right there. That's 2/3. Here's my second group of 2/3. This is 1/3 from the first hole and 2/3 from the second hole. So that's group number 2. The third group of 2/3, here's 1/3 and 2/3, so that's group number 3. Fourth group of 2/3, here's 1/3 and 2/3, that's group number 4. Group number 4. 1/3, 2/3 is group number 5, and 1/3, 2/3 is group number 6. So my answer, 4 divided by 2/3, is 6, because it takes 6 groups of 2/3 to make a hole, to make 4 holes. Okay. So now, there's actually other methods of dividing fractions other than just doing the keep, change, flip. So I want to show you one of the alternative methods. And depending on what curriculum you're using, you may be doing this. I know some homeschool curriculums use this alternative method, and I think it's shown in most classrooms. So just be aware that, like, depending on your curriculum, you may be doing things differently than the way you were taught, and that's okay. The goal of this class is to give you a toolbox of different ways to teach things, and also just to teach you to, like, open your mind that there's more than just one way to do a math problem. Okay, so the alternative method is using a common denominator. So using a common denominator. So if I wanted to divide 4 by 2/3. My first step would be to get a common denominator here. So how do I turn 4 into a common denominator that has a 3 on the bottom? You think, well, 4 is like 4 over 1. And how do I turn that into 3's? I multiply both the bottom and the top by 3. So I get 12/3 divided by 2/3. And again, you could get the picture of this if you need to. 4 holes. If I want to split each hole into a third, I'm going to have 12 parts. 3 make a hole. Okay, so now once you have a common denominator, so like step number 1 is get a common denominator. Step number 2 would be, now you just divide like normal. Divide across the top and across the bottom, just like you multiply. So what is 12 divided by 2? Well, 12 divided by 2 is 6. What is 3 divided by 3? 3 divided by 3 is 1. So my answer is 6 over 1, which is just 6. And that's what I did before. Okay, so one benefit of this alternative method of using a common denominator, when we add and subtract fractions, we have to have a common denominator. So it makes sense like to go ahead and get a common denominator when you divide also, because students have a hard time like, when do I need a common denominator? When do I not have to have a common denominator? This just kind of makes it where you always have to have a common denominator. So this could be useful definitely in certain situations. So let's do a couple more problems like that. If I had 3 2/5 divided by 2/5. So they actually already have a common denominator, but I have this mixed number over here, so let's make this into an improper fraction. 3 times 5 is 15. 15 plus 2 is 17 over my denominator 5, divided by 2 over my denominator 5. So divide across the top. 17 divided by 2, I'm just going to write it as 17 divided by 2. 5 divided by 5 is just 1. And so 17 divided by 2 divided by 1 is just 17 over 2, 17 halves. Or if you wanted to make it a mixed number, 2 goes into 17 8 times with 1 left over, and 2 still make a whole. 17 halves or 8 1/2. Okay, one more problem. If I had 6 1/2 divided by 3/4. So let me make it an improper fraction first. 6 times 2 is 12. 12 plus 1 is 13 over 2. Divided by 3/4. They don't currently have a common denominator. 2 and 4 are not the same number, but I can turn 2 into 4, and I can do that by multiplying the bottom and top by 2. So this is 26 over 4 divided by 3 over 4. So then 26 divided by 3, those don't divide evenly, so I'm just going to leave it as 26/3 or 26 divided by 3. 4 divided by 4 is a 1 on bottom, so my answer is 26/3. Or if you wanted to put in a mixed number, 3 goes into 26 8 times with 2 left over. 3 parts still make a whole. So that's your answer.